System word problems, part 2. So let's look at some of this. We have a tailwind, so of 4,200 kilometers. This is so cool, from New York to Mexico City. It took 5 hours. Against the headwind, so the return trip took 6 hours. Find the speed of the plane in still air and the speed of the wind. Okay? So we're going to need to know some science terms here. So we need to know this from science. So distance, d, equals rate times time. So we could usually write it like that. So we have two variables. My two variables here, I erased the highlight because I want to do the speed of plane. It's one variable. And the other variable is the speed of wind. So this becomes a very difficult problem. So we have speed of the plane, p, we'll call that p, plane speed, and we'll do w for wind speed. Okay, so now we need to think of our two equations. So distance equals rate times time. So we need to set up two equations. One for the tailwind, so let me box this in. Alright, so those are my two equations. The tailwind one, actually let me move those down a little so we can see what's happening. Tailwind and headwind. So, and we need to remember that it is rate times time, equals distance. I'm just going to write D-I-S-T. Alright, so rate. What is the rate? So let's look at the tailwind one. So the rate is the plane speed plus the wind speed when you're going with the direction of the wind times how long did it take times the time. It took 5 hours, and it equals 4,200. And the following one, the headwind, the rate, is P minus W times how long did it take? 6 equals 4,200. Right, so here is one way to look at it. These are my two equations, so I'm going to move those over and show you the... So I'm going to rewrite those differently and neater on the other slide, but those are my two equations. Alright? My rate, these are my rates. Those are my rates, and the time is right there. Alright, so these are difficult. So we can look at it like this, but just know that this is not the distance here. It should have... So I made one other box, which is the distance box. So again, this would be, the tailwind would be 5 parentheses P plus W equals 4,200, and the headwind would be 6 P minus W equals 4,200. So let's look at the work, how to solve this. So real quick, looking at this problem right here, all you do is divide by 5. divide by 5. Then we get this equation. And then for this one, we divide by 6, and we get this equation. Through linear combinations, you solve for P, and you get P equals the plane speed equals 770. And the wind was blowing at 70 kilometers per hour. All right, so this is tough. Let's look at another one. All right, downstream, we have salmon swam. So let me organize this. In yellow, salmon swam 144 feet. That's important. In 8 seconds. Then it turned around and swam the same distance back upstream in 24 seconds. Find the speed of the salmon swims in still water and the speed of the current. Okay. Downstream, 8 seconds. So I'm highlighting things together. And then swam the same distance upstream in 24 seconds. Find the speed of the salmon. So there's two variables here. Find the speed of the salmon, in still water, and the speed of the current. So those are our variables. Always what it's asking are the variables. What color have I not used? Pink. Yeah, that looks kind of pink. Those look both pink. That's going to be confusing. I've tried to color coordinate this. I know this might look confusing, but C is one variable. The speed of current. The other variable is S, speed of salmon. All right, so what do we have? We also have two other things that are going on. We have downstream and we have upstream. So I've made this. It's to help with these equations. So downstream I did in blue. It's light blue. So this is downstream. All right, what was the rate and the time? So the time is right here, and the distance, we know that, right? Those are the easy ones. The time is 8 seconds, and the distance is 144. But what do we, the speed, what is the rate? The rate here is the speed of the current plus the speed of the salmon, because they're working together. Upstream, on the other hand, which I did in light green, they're working against each other. So again, let's just 24 seconds is the time. 24 seconds is how long it takes to get upstream, and then the distance is the same, 144. Now, they are working against each other, so it's S minus C. The salmon is faster than the current, so that's how S minus C times 24 equals 144. All right, so now we're going to do the same exact thing. So what you're going to want to try and do is bring this over here by dividing by 24. So what I've done is I've boxed in right here. So what the first thing you do is divide by 8. So you get that. And the yellow one is as follows. You divide by 24, like I said. And then you're going to just linear combinations. I add these two things up, S plus S equals 2S, I get the speed of the salmon. And the salmon is going 12 feet per second, and the current is going 6 feet per second. Wow, that's tough, but I hope that helps. Again, let's look at this. The sum of digits of a two-digit number is 10. So that means the two digits, the ones place and the tens digit equal 10. The value of the number is 4 more than 3 times the units. So find the number. So let's try and write an equation. So the variables are tens place and U units, or 1. So let's start trying to, that should say slash ones place, okay? So those are the two things. So the first equation, the sum of the digits of a two-digit number is 10. That should be T plus U equals 10. Now the following equation is a little bit more difficult. The value of the number is 4 more than 3 times the units digit. If anyone got this, let me know and I will give extra credit, because that is very difficult. And you would solve it like this. So here's your challenge problem. If someone can solve this, please let me know and I will give extra credit.